Hello everyone, welcome to the SQRT channel. In this video, we are going to talk about a problem that we got from 1996 Nordic mathematical contest. In this problem, we have x to the power of n plus x to the power of minus n, and we want to find all x belongs to the real numbers, where for every n belongs to the natural numbers, we will have the value of x to the power of n plus x to the power of minus n be a natural number. Before moving forward to talk about the solution, make sure that you pause the video to think about this problem. To solve this problem, note that x to the power of minus n cannot be defined where x is equal to 0. So the function that we have is going to be defined for any value that we have not equal to 0. With that, let's start with writing the function that we have for a couple of different n values. Basically, for n, we have x to the power of n plus x to the power of minus n. If we use n minus 1, then we will have x to the power of n minus 1 plus x to the power of 1 minus n. If we repeat this for n is equal to 1, we will have x plus 1 over x. Now note that we want f of x for any value that we have for n belongs to the natural number to be a natural number. So f of n minus 1, f of n minus 2, all the way down to f of 1, for the x values that we are going to find should be a natural number. Now we are going to find a few different things here. First, we are going to start with x plus 1 over x times x to the power of n minus 1. We are going to end up with x to the power of n plus x to the power of n minus 2 here. On the other hand, if we multiply x plus 1 over x by 1 over x to the power of n minus 1, then we will end up with 1 over x to the power of n minus 2 plus 1 over x to the power of n. Note that on the left hand side we have x and 1 over x, and we also have f of n minus 1 of x. On the other hand, on the right hand side, we are dealing with f of x for n is equal to n and f of x for n is equal to n minus 2. Based on this, we can add the left hand side together and the right hand side together, and we will end up with the equation that you are seeing here. If you notice, we will have something that we can factor out on the left hand side, and on the right hand side we have some common terms that we are going to reveal in a bit. To be specific, we are going to write x to the power of n plus x to the power of minus n as x plus 1 over x times f of x for n minus 1 minus f of x for n minus 2. Now, since the function that we have should be an integer for any value of n, then we can say f of x for n minus 2, f of x for n minus 1, and also f of x for n, they all should be integer. So the thing that we need to find is x plus 1 over x should also be an integer. So our problem is reduced to finding what happens if x plus 1 over x wants to be an integer. X plus 1 over x can be written as x squared plus 1 over x, and we want to have an integer for this. Let's use m for the integer that we are going to have. We can simplify it and write it as x squared minus mx plus 1 is equal to 0. And now we are looking to find the values that we have for m in a way that x will be a real number and m be an integer. Now we have a quadratic equation and we want to find the roots that we have for this quadratic equation. Let's start with writing x is equal to m plus minus SQRT root of m squared minus 4 over 2. We are looking to find the real values that we can have for x, and we know m is going to be an integer. It happens when m squared is greater than or equal to 4. So m should not be 0, 1 and minus 1. Remember, we are just looking at integer values that we can have for m. So for any integer value that you pick and not equal to 0, minus 1 and 1, you can find the value that you can have for x, and you will see that x plus 1 over x will be an integer here. Thanks for watching the video. If you would like to see more puzzles and math involved activities, please subscribe to the channel. This is the SQRT channel.